on new test 2. By default, if you don't set your network security group settings, you will be able to have virtual machines on the same virtual network talking with each other even between subnets. But you can't say the same thing when it comes to applications and servers running on different virtual networks. So in this video, we're going to talk about a concept called peering. Peering is the idea of setting up a relationship between two virtual networks such that they recognize each other. And that allows virtual machines that are running on a virtual network to communicate with virtual machines running on another network because they recognize the IP addresses in their network space. Now, an important prerequisite for this is that the IP addresses that you've defined for your networks have to be non-overlapping. So if we look at new test 1, this is 10.0.0.0/16. And if we look at new test 2, this is 10.1.0.0. So these networks are not overlapping. So what we can do is we can set up the relationship between these called peering that allows servers on each to talk to the other. So if we go under settings, scroll down to peerings, we can see that we can now add a peering. Now it is possible for a virtual network to have peerings with multiple other virtual networks. In this way, you can set up what is called a hub and spoke model of network topology, where you have one centralized virtual network that has peerings with all of the other virtual networks that you have. And that way you can have spokes, in this case, that can communicate with other spokes. not every virtual network needs to be configured to communicate with every other. So let's just set up a very simple peering between two virtual networks. Under peerings, we're going to say add. Now this screen is a little complicated because it uses some very straightforward words to say, traffic to remote virtual network, but it's hard to really infer what that means. So in this single screen, we're going to be setting up two peering links, one for each direction. So from the virtual network 1, there's going to be a peering link that links it to 2, and then from 2, there will be a peering link to link it to 1. So it is a two-way peering, but that requires two peering links. So I'm going to call this VNet 1 to 2. Okay, so this first link is going to be traveling from VNet 1 to VNet 2. And so we can see here they've sort of grouped all of the settings below this here. First one says traffic to remote virtual network. Select this option if you wish to allow communication between the two virtual networks. I mean, that's pretty straightforward. Do you want to allow traffic? So we're setting up peering and we are allowing traffic. Now this traffic forwarded from remote virtual network. This is what in a hub and spoke model will allow traffic to come from one spoke through the hub to another spoke. And so do we want to allow traffic that does not originate from the second VNet to come to the first? I'm just going to let this settings be the default. Now you still do need a device that does the forwarding, so there's going to be a virtual appliance to do the forwarding, but this setting at least allows the traffic to travel. And finally, we're going to talk in a future video about network gateways, so we'll skip over this. So now we get to name the second link, and so this link is the reverse. So it is from VNet 2 coming into VNet 1. So whereas you can say this is an outbound link, this is an inbound link. I don't know why they still have this option. The classic model of deployment is well on its way out by now. Everything is resource manager model. Now, one of the interesting ways you can do is you can connect to link is the reverse. So it is from VNet 2 coming into VNet 1. So whereas you can say this is an outbound link, this is an inbound link. I don't know why they still have this option. The classic model of deployment is well on its way out by now. Everything is resource manager model. Now, one of the interesting ways you can do is you can connect to virtual networks that exist in different subscriptions if you know the resource ID. Okay, so if you can, if you have another subscription under your company, you can connect a VNet from one to the other, and you won't be doing it from a drop-down because they're in different subscriptions, but you can do it if you know the fully qualified name from the resource ID. Let's go back to the usual drop-down model here, and I'm going to pick new test 2 as the remote virtual network in this case. So this second setting, you see we saw traffic to remote virtual network allows VNet 1 to talk to VNet 2. This one is the reverse. It allows VNet 2 to talk to computers on VNet 1. So in this way, you can actually have a one-way connection where only servers on one network can communicate with servers on the other, but the reverse would not be true. So let's allow the two-way communication. And again, with the hub and spoke option of having traffic forwarded that did not originate from the remote virtual network, and we'll skip over this. So now we've got two deployments going on. One is going to deploy this VNet 1 to 2 peering, and then the other one's deploying the VNet 2 to 1 peering. So I'm going to give that a second to get that to a successful connection. And by hitting the refresh button, I can see now we have traffic traveling from VNet 1 to VNet 2. Now if we go into VNet 2 and go into peerings, we can see that second connection has been established that allows traffic to go from VNet 2 to VNet 1. So as we can see, Virtual network peering is a way of allowing two virtual networks who by default would not allow communication with each other to allow to have communication with each other. And as we were seeing, we are setting this up explicitly so we can control it, obviously. Now, they still do have to follow network security group rules and sources and things to talk to each other. Now let's add a third virtual network into our example, but this time I'm going to choose a virtual network that is halfway around the world from the United States in Japan. So this can be called global peering. It is possible to add a peer relationship between a virtual network in another region of the world and another virtual network. So I'm going to go into here, I'm going to create, this is VNet 3. I'm going to create VNet 3 to 1. Once again, I'll allow the traffic to travel over that, and should any traffic peering devices be added to the network, that traffic will be allowed to travel. Then we'll do the peering in reverse from 1 to 3. And so I'm connecting the new Japan VNet 3 network into East US 2. I'll leave all those defaults as well. So once again, we're deploying our peering relationships on both the new VNet 3 side and also the original VNet 1. So we can see here that the peering status says updated. If I refresh, it'll be in the process of updating. We switch over to new test 1 and into peerings. We can see now both peerings. So new test 1 is connected to new test 2 as well as new test 3. And so any devices on new test 1 will be able to access devices on both new test 2 and new test 3. Now, as I mentioned in the last video, even though we allowed traffic to transit between these spokes of the model and the so-called hub of the model, the forwarded traffic, there are no devices set up, no virtual network gateways or virtual machines or other devices set up that would allow to actually perform the task of forwarding the traffic. Okay. Now there is an important thing to note about doing this. So when you're setting up a peering relationship between a remote region and a local region, then you're going to start to think about the cost between traffic, because Azure does charge for bandwidth on a global basis. So if we flip over to the pricing page for virtual networks, we can see that by default, virtual networks themselves are free of charge, and each subscription can create up to 50 virtual networks across all regions. But what does cost money is the peering relationship. Now, even the two VNets that we did in the first video, that are VNet 1 and VNet 2, there is a cost of 1 cent per gigabyte for ingress and egress traffic, which actually means total of 2 cents per gigabyte. Because when traffic leaves VNet 1, it's charged at 1 cent per gigabyte, and when it enters VNet 2, it's charged at 1 cent per gigabyte. So you can see it says ingress and egress traffic is charged at both ends. So there's a little tricky trick there. 2 cents a gigabyte for VNet peering within the same region. That could actually add up. One can imagine that you'd end up with perhaps a few dollars a day of charges, and that could be $100 plus a month of charges if you have any kind of ongoing communication to talk about regions of the. It's going to cost us between two regions. That is global VNet peering with. Now, virtual network peering is only one way that we have to allow traffic to travel between two virtual networks. Another way we can do that is using virtual network gateways. Now, you might know that a virtual network gateway is also the device used when you want to set up a VPN, either a site-to-site VPN or a point-to-site VPN. A site-to-site VPN is when you're connecting, let's say, your corporate network to the Azure network so that they can communicate together. You have a virtual network gateway on the Azure side and an actual physical network gateway on the corporate side. You connect those two devices together and you can have communication, encrypted communication between them. So you can do the same thing between two virtual networks using virtual network gateway devices. Now what I'm going to do for this example is I'm going to connect another new test 2 region virtual network into new test 3, which is in Japan. Okay, so right now these two are not connected. So I'm going to go into new test 2. Now before I do anything, I will point out that if you go and look at the address space for new test 2, I have a really large /16 address space for this. But when I look at the subnet, relatively smaller address space for the existing subnet. So there is a pretty large amount of unallocated space. And if your subnet size and your address space is the same, you're going to have to increase your address space, because what we need is a second subnet called a gateway subnet. Now there's a menu item for this. I'm going to click Gateway Subnet. You can see Gateway Subnet is always named Gateway Subnet. You cannot name it anything else. It has chosen the next /24 space, so 10.1.1.0 to .255. I'm going to leave everything else as the default and click Save. So now I have a second subnet in which I'm going to deploy a network gateway. Now that takes a second to deploy here. We're going to let this take a second here. Now I'm going to go back to the dashboard. I'm going to create a new resource, and we're looking for a network gateway. In fact, it's the Microsoft Azure Network Gateway. So we're looking for a virtual network gateway. Okay, I'm going to say create. All right, so we're going to, this network gateway, the virtual network itself is in East US 2, so we're going to deploy the virtual network gateway to the same region. I'm going to call this VNet Gateway 1. And it is a VPN gateway, not an express route gateway. So we're going to choose a route-based VPN type. Route-based is more modern. It is a dynamic connection. I would suggest this is the answer unless you have an older VPN device. You're trying to set up a VPN network on your corporate site and it has a policy-based device. You're going to be forced to choose that one. Otherwise, you're going to choose route-based. Now we'll see here that we have a number of SKUs to choose from, which could be confusing. I'm going to choose VPN GW1. Now if we look at the pricing page for virtual network gateways, we're going to see that each of these SKUs has different pricing, starting at 4 cents an hour, 20 cents an hour, up to $3.65 an hour. And depending on whether you're using availability zones, that's another set of SKUs, starting at 36 cents an hour, up to $4.20 per hour. Your choice of VPN SKU is going to depend on your requirements, including how much bandwidth between the two devices, the number of site-to-site tunnels. So if you're going to have this site connected to multiple virtual networks, 10 of them are included, you're going to pay more for that. How many point-to-site tunnels, so if you've got a lot of employees working from home or need to be connected to the corporate VPN, that will also factor in how many are included, how much you pay. So we're going to start with this VPN Gateway 1 at 19 cents an hour. Okay? I'm not going to do availability zone gateway at this time. We only get one choice for generation. Now where are we going to deploy this? We just used VPN 2, so new test 2, and we created a gateway subnet already. I'm going to leave this public IP address type as the default, and it does need to have a public IP address in order to do this connection. So we can give this a name, public IP1, and we could, so active means that you have double the way that we're going to deploy into new test 2. Going to be the VN Gateway 1, and this is going to be deployed to new test 3. Now, I did not create the gateway subnet, and so it's going to go ahead and create that for me. That's great. We do also have to give this public IP address a name. So we'll just skip ahead. And when we come back in the next video, without using the... So when we last left off, we were in the process of deploying 2 virtual network gateways, one to East US 2 on new test 2 and one to Japan East on new test 3. Looking at the resource group, I can see that the public IP addresses have been created, and the second one still has some thing in progress. In fact, we can see what's going on by going in the resource group under deployments. We can see that we're going to go into a VNet Gateway 1, and we're going to create a connection. Right now there are no connections, and so what we're going to do is we're going to add what's called a VNet to VNet connection. I will name this VNet 2 to 3 because this is a virtual network 2, virtual network gateway 1, and the first one is obviously the one we're dealing with. The second one is virtual network gateway JPN. Now you do have to set up what's called a shared key, and this is a plain text password, if you will. I'm just going to call it my shared key. We'll leave the rest of the default settings. We have added the VNet 2 to 3 connection. You can see the status says not connected. So right now the connection is in a pending state. What we need to do is we need to add a connection in the reverse. We have to go into the Japan gateway under connections and effectively add VNet 3 to 2, which is a connection coming back in the other way. I called this my shared key. The key has to be the same. Leave all of the settings by default. Click OK. So we're creating the second connection between the two. We'll let this run for a second. Alright, after waiting a few minutes, you may have to wait 5 minutes or so to communicate VPNs and site-to-site VPNs and stage. And so savings on the traffic. At the cost of connection in order to do this VNet to VNet connectivity cross subscription using PowerShell commands. Well, so let's talk about how the domain name system works within Microsoft Azure. Now, the domain name system is sometimes abbreviated as DNS, and it's almost like the phone directory for the internet. It is how a domain name like Microsoft.com gets turned into an IP address, and it's the IP address that computers and servers use to communicate with each other. Now, this is an IPv4 address that also supports IPv6, which is a different address format. So your computer uses a domain name system probably provided by your employer or by your internet service provider to look up any domain that you're interested in visiting. That gets converted into an IP address, and it actually gets cached or stored on your local computer for a short period of time, and you don't go and look it up every single time. Now, within Microsoft Azure for virtual machines, there are 3 options for domain name services. Now, Azure does provide a DNS service by default. You can also provide your own DNS as if you're running your own DNS server, maybe inside your corporation or inside of Azure. And finally, there's a service called the Azure Private DNS Service that allows you to run your own DNS services. Now, the Azure provided DNS is, like I said, the default. So when you create a new virtual machine, it does have access to the internet, it has access to other computers on the same virtual network, and it can address them using their domain names, and that's provided by Azure's DNS. Now, you don't have to do anything to configure it. The other benefit of using the Azure provided DNS is that you can use what are called host names to connect to machines. So if you have a virtual machine on the same network as another, then you can just refer to it by its host name and it will be able to address it. And so you don't have to have .microsoft.com or .example.com to fully qualify the domain in the traditional sense. Now, there is also this private DNS service. This is a feature of the exam. Now, private DNS service only exists for your own benefit. It's not like you're buying a domain name on GoDaddy and having it registered in the public internet domain registry. You can create your own custom domain names and have them recognized by your virtual machines. And you can call them by familiar names like dev.local, staging.local, production.local. It's only valid on your network, and that means that you would not be able to access those domains from the public internet. Now, it doesn't have to be registered. It's not like a valid top-level domain or even a valid domain. The way that the Azure Private DNS works, it requires, they call them labels. And so there's a 2-label minimum, and labels are separated by a period. And so it's like dev.local is a valid 2-label domain name within the private DNS, and you can have up to 34 of them. That would be a bit excessive, but that might be something that you're interested in doing. Now, I should say there are some caveats. This is pretty much exclusive to virtual machines. If you wanted to have Azure App Services addressing virtual machines by some private DNS, you wouldn't be able to do it. You can't modify the name services, the DNS services for the Azure App Services, like the platforms as a services, like databases and stuff. So this is only for VNets where you do have access to modify their IP settings and what they use for DNS services. Should also say the big benefit to this is being able to address servers by a friendly name instead of having to rely on memorizing an IP address, so that you have dev.local, you know that's your dev environment. And even if the IP changes, you can map the dev.local to the new IP, and it's just you never have to remember it. And if the IP changes, you don't have to go in 50 different places and update all of that. So this is why you would use Azure Private DNS Service, and that it's available. Alright, we're going to switch over to the Azure portal, and we're going to look at the two different types of DNS zones that you can create. Now, I'm going to go under the top search box here, I'm going to type DNS. And we can see that there are two services in Azure that respond to DNS. There are public DNS zones and private DNS zones. To remind you from the last video, public DNS zones are internet recognizable. These have to be domains that are registered in a public registry. You have to prove that you have control of them, and then Azure would be able to accept any requests that come to it from that DNS, you would have to even modify your registry name servers. In the private DNS zones, it's internal to Azure only. You can have servers refer to each other by a friendly name, but it's not going to be recognized outside of Azure. So let's start with the private ones first. That's probably the easiest to demonstrate because we're not involved with a public domain. So I go into private DNS zones, and right now I don't have one, so I'm going to say create. Now we have to put this in a resource group. I'm going to put, say, AZSGD new DNS. You can call it whatever you want. Now this is the instance details is the zone name. Now the zone name is going to be that label.label that we talked about in the last video. So I can call this devserver.local. Now you could use a .com or a .net if you wanted to, but then you're going to end up with some type of conflict. Let's say I did put Microsoft.com in here, then my own servers would not be able to access the real Microsoft.com. You're going to end up causing confusion for yourself. So devserver.local or .dev or something like that is going to be the preferred way. Now they do give us a warning here that domain names ending in local may not work as expected with some operating systems. I've never had a problem with it, so we can leave that for now. But if maybe you want to have .companyname.com, right? You could have it as a custom subdomain that doesn't exist in the real world. That might be a clever one, but let's say .local. The location of the resource group, I'm going to create this in Canada. Okay? So once I've created this private DNS zones, then I'm going to be able to link virtual networks to that zone, and then the virtual networks are going to be able to access the domains that's registered in that zone. So let's create the private DNS zone. Call it create. It takes about 2 minutes, so I'll pause the video and we'll let that create. So we can see that it created it. It says 34 seconds, but yeah, just under a minute. So now we have a private DNS zone that we can work with. Now the next thing that we need is a virtual network. Now I do have some existing virtual networks, but I'm going to create a new virtual network. So I'm going to say add. And we're going to put it into the same resource group. So there's DNS group, and we're going to call this DNS VNet. And it'll also go into Canada Central. And I'll say create. You see that took literally seconds. Now if we go to the resource group level and refresh this, then we can see both the DNS zone and the virtual network. Let's go back into the DNS zone. And what we're going to want to do is link this DNS zone to the virtual network that we just created. So we'll go into virtual network links and we'll say add. So we're going to have to give it a name, and we can call this, first link. And we can choose DNS VNet that we created. We also want to enable auto registration. So as we create servers in the virtual machine on the virtual network, then it'll get auto registered into the DNS zone. Say OK. So as we can see, the DNS link is being established, and now it's completed. Next up, we're going to want to create a virtual machine. So let's go back to the DNS group, the resource group, and we will add a virtual machine. So I'm going to choose the Windows Server virtual machine. Hopefully you've done this a few times. Sort of new DNS VM. I'm going to take all the defaults here. And we can RDP, say that. Now instead of, we don't want it to create a new VNet. We want to place this, which location? I want to put this in the Canada one, which I created, Canada Central. Off, VNet and was auto assigned from the VNet. So that have been created on irrespective of the web likelihood of error. Reduces your dependency on private IP addresses where you can just rely on more friendlier names. Alright, so that was the private DNS zone. Let's look at what are called public DNS zones. I'm going to go back to the search box, enter DNS, and we'll see the service called DNS zones. I don't have any. Now, in order to operate here, we're going to have a domain name registrar that we could have a spare domain name that would be recognized from the open internet. Azure does not have a domain registrar in the traditional sense, and so this is going to require an external service. If you don't want to go and purchase a domain name, you don't have one available, you can just watch this video, you don't have to follow along. But if you do, then you can certainly go and try this yourself. So let's create a DNS zone. I'm going to put this in the same resource group, so I do have my DNS resource group. And again, we're going to call it, we have to give it a name, and this name is going to be the registered domain. Now, I happen to own a lot of domain names. Don't ask me why. I'm going to use this one, scottduffytraining.com, and I'm going to paste that here. So I am basically delegating Microsoft Azure to manage and to respond to this domain for me. The implications of this, I would not use a domain that you're already using for something else. So don't choose your main website domain, don't choose your email address domain, because when you set this up, you're basically telling the world that anyone who has any questions about scottduffytraining.com comes to the Azure DNS to get the answers. If you use an actual in production live domain name here, you're basically going to break that domain name. So always do one that you're willing to play around with. So this doesn't point to anything right now. It's a parking page. Actually, I can kind of prove that before we continue. So Scott Duffy Training, it's basically a parked web page with nothing on it. Okay. So let us create that as a brand new DNS zone. Now, simply doing this doesn't actually affect anything, right? So just the fact that Azure has a DNS zone with a domain name is nothing's going to change, because what I have to do is I have to modify my registrar. So now that I've created this DNS zone, I can see in the top right corner I think it's here, and taking effect. Now the way that you know that it's worked is when you're able to do an NS lookup of the domain name, so the propagation has effectively worked, and we can continue on, adding this domain, like creating a VM anymore, which is exactly what we expect because we haven't set it up yet. So one of the easiest things we can do is to go back to the VM that we created for the last lesson, if you still have that, and turn this into a web server. So I can add features, go down into web server, I don't really have to set this up, web role. I don't really care about the features as long as there's a web server. So I'm just going to have it become a web server really quick. Remember, we had delegated this to web.devserver.local. I also could delegate it to www.scottwtraining.com. Both can work in tandem. So I'm going to set up the web server here, and then I'm going to add a record for the www in the DNS here. So installation of IIS worked. I can go into the server, open up Internet Explorer, and then say localhost. You can see that IIS is successful here. I do have to, let's go back to here, go up to the resource group, Alright, so there's two more things that we need to do in order to get this new custom domain name recognized from the internet. One of the things we need to do is we need to allow port 80 traffic through the network security group. So you need to find the network security group that belongs to the web server. So the web server is new DNS VM in my case, and so I need this network security group. I need to go into inbound security rules. When we set this up, we only allowed RDP traffic. We do need to allow web traffic, and so I'm going to switch over to the basic setup, and I'm going to pick HTTP. I'm going to rename this to port 80 and say add. And so you see port 80 got added as an inbound rule. Now if I wanted secure traffic, I would have to add 443 as well. We don't need to do that. That's the first thing. The second thing we need to do is go into the DNS zone, and we need to allow, the www subdomain to pass through to the correct IP address. So I'm going to say record set. I'm going to say www, and we're going to make this an A record, which means it accepts an IP address. Now the IP address of the server, public IP address, we know it from our RDP session. It's also in Azure. So I'm going to just type in the public IP address, 52.233.1.183, and say OK. Right? So now the DNS zone recognizes the subdomain, and we know the traffic's going to be allowed through the network security group. Let's test it to see that it works. So I'll go back to the browser on my local machine here, and it does hide the www, but you can see that that's the fully qualified name, and it brings me up the IIS loading screen effectively. So we've successfully created a public DNS zone in Azure. We've successfully created a custom group at the registrar level, and then we're able to basically pass traffic over our subdomain here. So that's how within Azure that allow custom domains. And so in this section we're going to be talking about network security groups. Now, we already talked about the concept of virtual networks and how we create these networks. Inside of them are subnets, and running on subnets are devices such as virtual machines that have a network interface to get onto the subnet. So you've got virtual machine has a network interface. The network interface connects to the subnet, and the subnet is part of a overall virtual network. Now, these devices that are connected to a virtual network communicate with each other over these virtual network paths. The network security group allows us to specify which type of traffic is allowed and which type of traffic is blocked. It is basically an allow/deny metaphor for letting traffic pass over the network. Now, the network security group can either be attached to the subnet or it can be attached to the network interface. So if you think of this as being a tunnel, on one side is the virtual machine with a network interface. On the other side of the tunnel is the subnet as a whole. You can put your network security group on either side of the tunnel. It's still going to allow or block traffic traveling over that tunnel. So let's take a look at this in action. So we have a virtual machine connected to this default subnet. The subnet has this address range. Okay. Now, if we go into the virtual machine, we can see the network interface. The network interface actually tells us in this summary section that there is a network security group attached to the network interface. So this, in this instance, is attached to the network interface, and if we go back to the subnet, then we do not have any security group attached to the subnet. Okay, so in this instance, the security is on the virtual machine side. Let's go to the network security group. This was created when we created the virtual machine. So if we didn't specify it, it would create this new one for us. I'm going to go into it. Now, by default, the network security group has a number of rules. It splits the rules into inbound rules and outbound rules. So you can look at this as being traffic coming into the virtual machine over that virtual network interface card, and traffic that's leaving the machine. Let's have a look. I'm going to go to the inbound security rules tab here, and we can look at them in a little closer detail. So this is the default configuration. I have not added any other rules into the inbound security of this virtual machine. So By default, it allows traffic to come from another machine running on the same virtual network. Okay, so any port, any protocol over this virtual network is allowed to come into the machine. So by default, and the subnet is part of the overall virtual network. Now, these devices that are connected to a virtual network communicate with each other over these virtual network paths. The network security group allows us to specify which type of traffic is allowed and which type of traffic is blocked. It is basically an allow/deny metaphor for letting traffic pass over the network. Now, the network security group can either be attached to the subnet or it can be attached to the network interface. So if you think of this as being a tunnel, on one side is the virtual machine with a network interface. On the other side of the tunnel is the subnet as a whole. You can put your network security group on either side of the tunnel. It's still going to allow or block traffic traveling over that tunnel. So let's take a look at this in action. So we have a virtual machine connected to this default subnet. The subnet has this address range. Okay. Now, if we go into the virtual machine, we can see the network interface. The network interface actually tells us in this summary section that there is a network security group attached to the network interface. So this, in this instance, is attached to the network interface, and if we go back to the subnet, then we do not have any security group attached to the subnet. Okay, so in this instance, the security is on the virtual machine side. Let's go to the network security group. This was created when we created the virtual machine. So if we didn't specify it, it would create this new one. just going to go into it. Now, by default, the network security group has a number of rules. It splits the rules into inbound rules and outbound rules. So you can look at this as being traffic coming into the virtual machine over that virtual network interface card, and traffic that's leaving the machine. Let's have a look. I'm going to go to the inbound security rules tab here, and we can look at them in a little closer detail. So this is the default configuration. I have not added any other rules into the inbound security of this virtual machine. So by default, it allows traffic to come from another machine running on the same virtual network. Okay, so any port, any protocol over this virtual network is allowed to come into the machine. So by default, two virtual machines running on the same virtual network are able to talk to each other. Okay, that makes sense. And also by default, if you have a load balancer running on this virtual network that is, sitting in front of a virtual machine, then that load balancer is allowed to talk to the virtual machine. So again, any port, any protocol, this is the load balancer situation. All other traffic attempting to get into the virtual machine is blocked. So this is the deny action. So other computers, the load balancer allowed, everything else blocked. What this means is if I was to attempt to RDP into this computer from my desktop here, then I should hit this rule saying deny all inbound because I do not have the RDP port open for inbound traffic. Why don't we go ahead and add the RDP port for inbound. So I say add, and what we want is the source is going to be any for now, but ideally we want a source to be our network or our computer specifically. So I could actually say I want only my computer. If I did, it got my IP address. So what is my IP address? I could limit the traffic that is coming inbound over this RDP port to my computer that is located at this address. If my ISP was to change the IP address of my computer, then this would stop working. I can also do this in a CIDR configuration, so I can say /24, and that will cover all IP addresses on this from 0 to 255 in this case. And what we want to is basically send traffic to any destination, so we don't have a specific computer in mind, although we could put the private IP address of or the public IP address of this computer, but we won't. And the question then becomes which port. Okay, so the port for RDP traffic is 3389. Okay, so that is the standard port for RDP traffic to go from over the network. RDP traffic is TCP. We might as well block off UDP traffic, and we want to allow RDP traffic. Now the priority works by the lowest number having the highest priority. So you'll see that the default rules are a very high number, 65,000 up to 65,500. And so we can set the priority. The default was 100. I'll set it to 1,000. And we're going to call this RDP traffic. And so if I was to add this rule, because we put a source IP address, only computers on my network will be allowed to RDP over port 3389 to any computer that is subject to this rule. And for now, this is again on the network interface card, so it's only that virtual machine that's affected. I can do the same thing for HTTP and HTTPS traffic. There's actually another way of adding this. This is set to the advanced by default. If I say a basic, then I can choose from a drop-down list for, let's say, HTTPS traffic, and you'll see that it fills the ports in automatically. And I can call this HTTPS traffic. So let that add. And similarly, we can do the same thing for HTTP traffic. Okay, so this is HTTP traffic. Now, if we were doing, this is for Windows, obviously, the RDP port. If we were doing Linux, we would have to add the SSH port, which I believe is 22, but don't quote me on that. So basically, now we've allowed 3 traffic sources. 2 of them are from any source IP address in the entire world, and 1 of them is just from the limited set of addresses on my ISP's network. Okay, so that's the inbound traffic rules. Let's switch over to the outbound. The outbound is basically wide open. Okay, so this rule is saying that from this computer, from this virtual machine, it is allowed to talk to any other virtual machine on the same virtual network, allowed, and it is also allowed to talk to the internet. So that is internet traffic. So basically any computer on this network and any computer on the entire internet. All other outbound traffic is denied. But what other outbound traffic would there be besides the internet and other machines on this virtual network? Okay, so maybe we would, if we would want to do VNet peering and have other computers on other virtual networks, but otherwise the outbound rules are pretty open. The inbound rules are pretty closed. Okay, So that's the basics of a network security group. We're going to look at assigning this network security group to other virtual machines and to even to the subnet in the next video. So I've created a second virtual machine using the portal. And we can see here in the resource group that there are now two network security groups that serve specific roles. If you have 100 virtual machines in your production environment, you definitely do not want 100 network security groups. Not only does that create extra clutter in your interface, it actually is a security risk, because if you need one set of network security group rules like the RDP, HTTPS, traffic, etc. If you have back-end servers, you might need different network security group, other network interface 68 here. What we want to do is associate this device with another network security group. So I'm going to go over to network security groups here on the network card. We're going to say edit. And instead of this network security group, we're going to switch over to the other one. In which we just calculate it again. And so we can see that. So this is a second virtual machine using the portal. And we can see here in the on this from 0 to a virtual network communicate with each other over these virtual. Now the network security group can either be attached to the subnet or it can be attached to the network interface. So if you think of this as being a tunnel, on one side is the virtual machine with a network interface, on the other side of the tunnel is the subnet as a whole. You can put your network security group on either side of the tunnel. It's still, so let's take a look at this in action. So we have a virtual machine connected to the virtual machine. We can see the network interface. The network interface actually tells us in this summary section attached to the network interface. So this, in this instance, is attached to the network interface, and if we go back to subnet, okay, so in this instance, the network security and outbound rules, it would create this new one for us. I'm going to go into it. Now, by default, the network security group has a number of rules. It's split. Next section. So in this section of the course, we're going to be talking about the concept of a load balance. Now, what is a load balancer? You can view it as a device that basically distributes any kind of incoming internet traffic over multiple servers that are connected behind it. And usually this distribution is quite even. So if you've got 4 servers behind a load balancer device, then usually you'll have 25% of the traffic going to each server. Now, there are different algorithms that you can choose, so this is not universally true. You can also have servers of different sizes, and so maybe intentionally you want to send more traffic to different servers. There's many reasons why this wouldn't be true, but you can view it simplistically as evenly distributing traffic to 1 or more servers that are behind the load balancer. Here is a simplistic diagram that shows 2 load balancers. At the top of the diagram, you have a cloud, which represents the internet. You have internet traffic coming in over port 80, which is the HTTP port, and the public IP address is the public load balancer. That public load balancer then distributes traffic over port 80 to 3 virtual machines that are behind it, and this is the web tier. And so, because it's a public load balancer, it is accessible from the outside, and each web server takes turns responding to the traffic. Now you can take this a step deeper and have the web servers themselves connecting with an internal private load balancer in order to connect with the back-end tier. You could do this over a secure channel such as HTTPS port 443. And so in this way, the customer that is on the internet is served traffic from one of 3 servers, and that server itself is served the data that it needs from one of 3 servers behind. And so this is a common setup where you have both public and private load balancers. Now you don't have to have a load balancer. Sometimes you can just load your workload onto a single VM and have that single VM serving traffic directly to a public IP, and you don't require to be able to scale that and have a load balancer in front. That's typically for what's called a non-critical workload. So that would be something where if it is overwhelmed with traffic, it's not going to impact your business operations in any major way. But in real world, when you have public-facing servers, you have to, account for the tendency for servers to sometimes come under heavy load. It could be legitimate traffic, or it could be even malicious traffic in terms of a denial of service attack. What do you do when you've got that server that can't handle the load that is being given from traffic? Well, you do have the option of scaling to a larger server. So you could go in either in an automated fashion or a manual fashion and say, let's take this 4 CPU VM and make it an 8 CPU VM. And by doing that, you're able to serve, hopefully, way more traffic, assuming this number of CPUs was one of the bottlenecks, right? So 16,000. 96 CPU server, and you CPU benefits and benefits 1,000 up, but to scale out. And that means adding more machines into the mix. And so this is an example of scaling out. You've got 3 web servers, and then 5. So the basic SKU is the smallest one, obviously, only supports basic features. It is free. So if you need a load balancer, but you're not willing to pay for it, you can use a basic SKU load balancer to change the port number. Availability zone 1, and this VM's in availability zone 2, and you need the load balancer to be deployed to those availability zones itself, then that type load balancer into the search. Full of options. What it does is it relies on the source IP, the source port, the destination IP, the destination port, and whether it's TCP or UDP or whatever type of protocol wizard for creating it. I'm going to create a new resource group. So I'm going to wizard for creating it. I'm going to create a new resource group. So I'm going to call this load balancer. And we do have to give it a name. You'll find one that is unique for you. I'm going to level of the SKU, network, any virtual machine or any virtual machine scale set on a single virtual network. And for basic, it has to be on a scale set or an availability set. So it does not support single virtual machines as the back end. So you can see things are pushing us towards the standard diagnostics options for Azure Monitor. And finally, we can talk about this tier. Do you want your load balancer ready deployed only to the East US region, or do you want to run this as a cross-region load balancer? So it'll be deployed to, let's say, EastGS 2, but it actually supports VM scale sets and availability sets and other things across no zone redundant behavior. I'm going to turn off availability zones. And I'm going to say add. So now we have a front end. But if I was to create a rule, I could say health probe associated with it backend pool. We're going to say review and create. It's done. We'll go into the load balancer and we will create the. Alright, so we have a load balancer running and it has a front end public IP address, but it's not connected to anything. We don't have anything in the back level. So what I decided to do was create a virtual C. Now I want to add it to the backend pool. So I'm going to go back to the home. I'm going to go back to the load balancer. We're going to go under backend pools. Now there is a prerequisite when we're creating a backend pool. Give it a name. Call this LB pool 1. So all the machines that choosing it by NIC card or by IP address, and we do have an IP address for this machine, so we could put the IP address, but I'm going to choose NIC card. So I'll say add, and now we'll see that I have this resource as an available option. Now I can say save. Now this load balancer running with a single virtual machine, detect a single virtual machine, just that you anticipate sometimes there's two, sometimes there's. So now we have our front end, we have a back end, but we don't have any traffic going from the front end to the back end. Before we can do that, we need what is called a health probe to accept traffic. So I'm going to call it probe 1. Now we have a couple of options for health probes. We can do a TCP probe. That is a level 4 probe. It checks to see if the port opens. Let's say port 80. Does it open? Yes, it's a successful probe. Does not check to see that IS is running. Could have probe fails to access. We'll add the health probe that we find. Front end configuration. Front end configuration does have an IP address, so we can go direct by the public IP address of the VM, or we can go through the load balancer and see that. Now if we had more than one virtual machine connected to this load balancer, we could test by stopping one of the virtual machines and seeing if load balancer continues to work, etc. But we're not going to do that. That's a step too far. So now we have a load balancer with a backend to the backend server. Now, Microsoft does a pretty good job of providing documentation, Microsoft Learn, and GitHub resources. I'm in GitHub right now under the Azure user and the Azure Quick Start Templates repository. A link will be provided attached to this video. The Quick Start templates are an easy way to find literally hundreds of examples that you can deploy into Azure. Now you can see here there's been 30,000 commits over the years, and so this thing has just been growing and growing. There's even a website for it. Now they've recently changed the way that this repository is organized, and so if you've seen this video before, it's now different. I'm going to go into the Quick Starts submenu here, subdirectory. Now they've basically organized it according to the core technology here. So you can see API management quick starts are under one area, compute quick starts, the CDN, any kind of thing that you want to learn, you can go and check out the quick starts and you'll be able to find it. For this example, I want to look for a load balancer. Load balancer is under networking, so it's Microsoft.network. I go into there. So I can see under the networking quick starts, again, there are dozens of things from express route and firewall, bastion service, gateway. So I want to find a load balancer. I'm just going to do Control F. And I know that there are different versions of that. We've got IPv6 load balancer, cross-region load balancer. The one that we're interested in is called Load Balancer Standard Create. Again, this has changed a little bit since the video I made a couple years ago on this. Now, another cool thing about GitHub is in this quick starts, there's just this button here that says deploy to Azure. There's also a visualize button. So I'm going to click the visualize button, and we're brought into this ARM Viz website. We haven't really talked about it before, but what it's done is it's interpreted the ARM template, and I can scroll in here and I can see that there is a compute resource, that there's virtual machine here, IP address, couple of IP addresses, so we can sort of visualize the resources that are inside of this project. So let's go back to the GitHub repository here, to this ARM template for load balancers. So now I'm going to go and deploy this load balancer. It's going to open up the portal, and it's going to grab this quick start template for me. You can see that it's load balancer standard create from GitHub. I do have to fill in some details. I have to create a resource group for it, so I can say AZSJD new LB, put it its own resource group. I'm going to choose a region for it. I'm going to put this in East US 2. This project name basically is going to feed into the names of other resources. So this is like a prefix that's used when creating all the other resources. The location, you can see the default is going to pull from the resource group location, so this happens to be East US 2. I'll leave that. For the virtual machines, I have to give it user ID and password. And you can see that it's defaulting in this case to a DS1, which is a relatively small, and which is fine with me. I can say review and create. You'll see there are 12 resources that are going to be created by this ARM template. And so I should be able to hit create. Now this is basically deploying the quick start template directly from GitHub, and I think this is pretty cool, the way that I found a resource that I want to play with, and I'm just able to hit deploy, provide some details, and it goes off and does that work. So this is one of the really cool things about ARM templates. So while this is deploying and we can see the resources are being deployed here, let's go back to the GitHub repository for ARM, those quick start templates. And like I said, I think this ARM templates are really a neat way to deploy resources for testing. I think there is a certain amount of ARM template knowledge required for this exam, and so it is probably in your best interest to spend at least some of your time looking at the way that ARM templates are created. So pick something that you find interesting, find the ARM template for that. There's some bicep in here as well, which is pretty cool. And look at the way that the ARM template is configured, the various properties of this JSON file, how parameters are passed, how resources are specified, because there is a good chance there's going to be a couple of questions on the exam relating to ARM templates. Not that you have to write them, more that you would have to understand what would go in a particular value, or what would be the parameter name. So if this parameter name was missing, you should be able to determine what is the likely parameter name from a list of predefined options. So yeah, ARM templates, quick start, the link is attached to this video. Definitely check it out. So we have successfully deployed the load balancer, 3 virtual machines, 3 network interface cards, public IP, network security group, virtual network, using that template. And we can actually go into deployments of the resource group, and we can see that the template deployment succeeded, and it took around 7 minutes to deploy all those things. A lot simpler to do than to set them up from scratch yourself. Now let's go into the load balancer. So the purpose of this video is to look at all of the things that can go wrong with a load balancer setup, and what I would do to diagnose those. Now I want to start off by saying that there's really only 4 or 5 setting blades within a load balancer. We can see them listed as front end, back end, health probes, the load balancing rules, and the network address translation rules. There's also the outbound rules, but that's not a very rare thing that people are going to set up outbound rules for traffic. Okay? So what can go wrong with your front end configuration? Well, of course, this is the IP address that's available to the world, right? So if you're going to enter that IP address into a browser, you're going to get some type of result. It's pretty cool that this template has a running web browser that says hello world and the name of the server as part of the configuration. So a thumbs up to the template that does that. That could be an Nginx or something type thing. So the IP address is what is connected to the world, of course. And so if you're using a domain name, you have to make sure that that domain name resolves to the correct IP address, that's all set up for domain resolution. Now the IP address is associated with rules. So this will be under load balancing rules. But if I go under this, I can see that it's HTTP LB rule. Okay, that's what the rule that it's associated with. Now, if I go, I'm gonna do that later on. Go into the next one is backend pools. So what can go wrong with your backend pools? Well, first of all, are you pointing these load balancer to the correct servers? And so you might have 1, 2, 3. You might have several backend pools that are all resolved to answer for this traffic. You can see here that one of my virtual machines is in a stop state. I just stopped it myself. And so one of the things that could be happening, of course, is that only 2 of your servers are doing the work, and the 3rd server is never called upon, right? An unequal distribution of traffic. Now, the reason why VM3 never gets called, I can keep refreshing this all day, it's going to be 1 and 2, is because of the health probe. So the health probe is what decides whether the backend pool is returning a normal response. So if we go into the health probe, we can see that this is an HTTP probe. We do have the choice between TCP and HTTP. Now, since this is a standard load balancer, we can also do HTTPS. That's not available in our basic load balancer. So this is going to check using HTTP protocol the root document on port 80 for the web server that's located on each of those servers. It's going to check every 5 seconds, and 2 failures basically removes that server from the distribution. Okay? So this server, let's go back up to here, go to backend pools. This server that is deallocated has been kicked out of the pool based on the health rule. I can actually click on this and say start. This is a DS1 1 CPU. It's a small machine. It's going to take a minute to start up, but we're going to start that up, and then hopefully we'll see VM3 start to get responses from our calls. Now the 4th critical part of a load balancer, of course, is the load balancing rules, and we saw the front-end IP addresses connected to this rule. And this rule basically takes the front-end address and will send all traffic from port 80 inbound to port 80 on the server. And so if you're trying to do something where you're accepting traffic on, let's say it's 8080 on the back end and 80 on the front end, that's more of a network address translation setup, but it doesn't have to be the same port. You can actually do this type of redirect. So you're going to have make sure that your server is listening on that port. This is the pool that contains the virtual machine. So make sure that your load balancer rule goes to the right pool. Again, the health probe has been chosen here. Now, session persistence is whether the same user gets sent to the same server every time, or whether you can have any server responding to that user. This concept of idle is basically the client and the server have this open connection as opposed to it being closed and then having to be reopened. It's a very you wouldn't want to set that up if you've got so many clients, because that's just a lot of open connections, and it's just something that the server needs to keep in memory. There's taking up resources when you have this. All right, so we're going to leave the load balancing rules as they are. If I go back to the backend pool and I open this up, I keep doing that. I see that the VM3 is now running. So it would be interesting to see if we can get our VM3 to respond to our browser. And yes, as soon as I hit refresh, VM3 is one of the ones that's able to respond, and in fact, quickest to respond right now. The final section is NAT rules. Now, we don't have any set up, but network address translation is more specifically when you're taking in traffic over one port and sending it basically a port mapping to the target port. It is, incoming traffic sent to a selected IP address and port combination to a specific virtual machine, as opposed to the whole group of them. So if you're looking for that kind of setup, then this is where you're going to debug any kind of problems with that. We don't have any of those. Now, if you do need to configure rules for traffic leaving the virtual machines traveling through the load balancer, then you can set them up in the outbound rules here. So in terms of debugging your front end being set up correctly with the correct load balancing rule, your back end being set up correctly, your servers all in a running and proper state, your health probes pointing to a proper location that would successfully tell your load balancer whether or not it is healthy properly, and finally the rules themselves that tell you which traffic can get through and which traffic cannot. So for instance, right now we don't have an HTTPS rule, and so that would be basically blocked by the load balancer. Now I should also mention that you can set up an alerts process so that if there's ever any health probe issues, back-end servers that are not responding, that a particular alert group is going to be notified, or an action group here. So we can say the resource is the load balancer, that under the condition we can choose the we can see here some of the signals available, health probe status being one, the number of bytes being sent through, the number of packets, whether or not the load balancer, these are more administrative, you wouldn't necessarily set these up, but health probe status is a good one. And so we can see the health probe was having problems. I restarted the server, and number of problems are going to go up and go down, right? So we can choose the, we don't need to, basically we can say more than 5 failures in 5-minute period means that you're going to get a notification in your alert, your action group here, and that could be an SMS message, it could be an email, that could be some type of job that kicks off, etc. So setting up alerts is another way of figuring out health probes are failing and your load balancer is having difficulties. So we've just seen the load balancer, which is what's called a layer 4 load balancer. It operates at the transport layer. The load balancer that we've seen only understands things such as IP addresses and ports. And so when you're setting up the rules for load balancing, you have to choose the source IP, source port, destination IP, destination port, and protocol type, which is TCP or a UDP. So that is the transport layer of the network stack. What the load balancer does not understand is a URL. It doesn't understand the path. Okay? If you need to do load balancing based on what the user has typed in the URL, you need to go at a higher level of the network stack, and that's called an application gateway. So if I go into application gateway here, this is also a load balancer, but it is layer 7, and so it understands HTTP rules. Now the other benefit of an application gateway is you can have optionally a firewall associated with it. Now with application gateway, there is no free application gateway. So unlike the basic load balancer, which doesn't cost anything, the choice of application gateway is basically going to have a price no matter what we choose. So AZSJD new app, AZSJD new application gate. Give it a name. Region, I'm going to stick to East US 2. Now, the first major decision we have is in terms of the tier. Okay, so based on our choices, we're going to have the standard or standard v2 tiers, or the web application firewall, or v2 tier of that. So this, of course, the standard application gateway can direct traffic just like a load balancer, where the web application firewall actually can parse the traffic coming through and block traffic that is known to be of a suspicious type. So a SQL injection attack or cross-site scripting and those types of standard attacks, a web application firewall can block them. So I'm just going to choose the standard tier. Now, another feature that Application Gateway supports that a load balancer does not is the scaling of the gateway itself. And so if I just said no, then I'm going to have, in this case, 2 static scale units of Application Gateway. If I say yes, I can scale from 0, in this case, 0 to 10, such that if the traffic demands it, it's going to basically spin up more of application gateways to support the level of traffic. I can also place application gateways into specific availability zones. And so if I'm setting up my environment for high availability and I want to place virtual machines into zones and put my application gateway into zones, I can set up my true high availability environment because I'm actually physically placing those services where I need them to be. I'm going to let Microsoft decide where that goes. Another difference between Application Gateway and a load balancer is Application Gateway is like a device that lives on your availability environment because I'm actually physically placing those services where I need them to create it. You see standard v2 doesn't support internal pool. Now the cool thing about Application Gateway is it does have more options for the backend pool. So you can have web apps as app services in your backend pool, virtual machine scale set, virtual machines, or what's unique to an Application Gateway is the IP address. And so you can even have servers that are hosted in your own environment that have that. So we're going to leave the backend pool empty. These settings. You can't have clients going between multiple servers based on different paths. So if you've got, well, unfortunately we only have the one backend target, but if we had more than one, we can say, everything that's /videos goes to these servers over here. You can click review and create. And so Application Gateway can actually benefits to Application Gateway over a load balancer, and that's as easy as it is. So in this section of the course, we're going to be talking about monitoring and troubleshooting networking within Microsoft Azure. Now, as you might expect, when you're dealing with virtual networking, things get a bit more complicated when it comes to monitoring the activity over that network. If you had a router and wires in your own premises, in your own data center, you can actually run packet sniffers and check the traffic running over the wire, and that would be a pretty reliable way of seeing what packets are going back and forth. But in a cloud environment, everything is shared. There are millions of Azure customers using the same cabling, the same physical architecture, and so we have to do everything in much more of a virtual way. So in this section, we're going to be looking at the monitoring and troubleshooting of network. In order to do that, I'm going to start by setting up a virtual network and having a couple of devices connected to that. So I am going to basically fast forward here through the creation of a virtual machine, attach that virtual machine to a virtual network, and have another virtual machine attached to a separate subnet on the same virtual network. So you'll have two machines on two subnets on the same virtual network. So I'm going to fast forward through this, and when we come back, we'll have that topology. So really quickly here, I'll create a virtual machine. I'll wait for the virtual network to be created, and then I'll create a second virtual machine attached to a new subnet on the same virtual network in the same resource group. All right, so now we have a virtual network that has fairly standard address space of 65,000 addresses. It's /16 address space. I said we created two subnets, and so these are separate networks within the overall virtual network. And on those subnets, we have two network interfaces which are attached to virtual machines, one on each subnet. So the theoretical question that we have here is, what do we do? How do we figure out if, let's say, one of these virtual machines is having trouble communicating with the internet, or if one of these virtual machines is having trouble communicating with the other? What is the, in a world of very complicated rules, NSG rules, or routing tables, or firewalls, where does the communication break down, and how do we figure that out? And that's what we're going to find out in this section. So what we have here is our little demo, and so I'm going to stop the video for now. In the next video, we'll start to look at a tool called Network Watcher. Now, in order to find Network Watcher, there's many ways to get to it, as we know. I'm going to go into the All Services, which is these three parallel lines in my menu. I'm going to go under Networking, and I can see Network Watcher. Obviously, I can favorite it and add it to my menu. I can search for it in the top toolbar, etc. So let's just click on Network Watcher. Now, there are some legacy Network Watchers here where, over the years, I've had this account for many, many years. It used to be that you had to create Network Watcher whenever you needed it. So now, as we go forward in 2022 and 2023 and beyond, it is created for you. Okay. So now we're in Network Watcher. We can see that each region that we have resources has its own Network Watcher. If we don't have resources in that region, or we used to have resources in that region, then it wouldn't be on this list. Now, I created this virtual network and these virtual machines in the North Europe region, so I can know right away where my resources will be found. On the left, we can see that the Network Watcher tool is actually two tools, or two groupings of tools in one. On the one hand, we have the monitoring tools, and so these are topology, connection monitor, and network performance monitor. And we also have a group of tools under diagnostic tools. And so this is where we're going to see where the flow of traffic is going through, diagnosing our network security groups, what are the computed effective security rules, etc. So let's start off by choosing the topology tool on the left. Okay. So I choose the topology tool, and I do get to select which resource group that I want to view and select which virtual network I want optionally. I can see with my new resource group that I have this brand new virtual network, and it has two subnets, and there are two network interface cards attached to those subnets, and we have a virtual machine, network security group, and a public IP address on each public network. Okay? So this is a topology tool, and this is a good way of visualizing our virtual network, or if we have multiple, we can visualize those multiple virtual networks. You can see the download topology button, which will allow us to take this map offline. Okay. Next, we'll look at the connection monitor tool. The connection monitor tool is a way to check that connections work between two Azure resources. So if you want to verify if the two VMs that I just created can communicate with each other as it sits, we can use this connection monitor to validate that. And we'll do that in a future video. So we can then create ongoing monitors, and we can actually see if there are issues. For instance, some of these things, I don't think they exist anymore. The status is question mark. And so at some point, what I'm going to do right now, I'll just delete the old monitor that no longer needs to exist. So connection monitor will check to see the connection between two Azure resources, and if there is an issue, why it occurred and how to fix it. So there's diagnostics here. You can connect to IP addresses, you can connect to fully qualified domain names. So if you want to check if your virtual machine can connect to www.microsoft.com, you can also set up a monitor here just to see if that. The third monitoring tool is the Network Performance Monitor. So you can see there's a banner at the top saying we're retiring Network Performance Monitor.
Let's take a look at how data flows into Google Analytics and how that data is processed to create insightful reports. To connect your website to Google Analytics, you'll need to add a tag to your site. A tag is a small piece of code that is added to each page on your website in order to measure user behavior or add functionality. Tags can be added directly to your website's code or by using a tag management system like Google Tag Manager. There are several ways to tag based on how your website is built. We'll cover this in more detail later. Once the Google Analytics tag has been added to your website, the tag will collect information about users like the device type and their geographic location, and how they interact with different pages on your website or app like page views and form submissions. As your customers engage with website or app content, these interactions are sent to Google Analytics as events. Many common interactions are automatically collected as events in Google Analytics. For example, when a user first visits your website or app, Google Analytics will log this action as a first visit or a first open event. And when a user clicks an outbound link to leave your site, GA will record this as an outbound link click event. As events are collected, they are processed and then turned into information you can see in reports. You can then analyze this data to gain specific insights. For the Google Merchandise Store, Analytics can show how many users visit a page that sells clothing compared to a page that sells housewares. Or it could show you how many users purchased an item like an Android doll by tracking whether they made a purchase on the confirmation page. In order to collect data from apps, you'll need to add the Firebase Software Development Kit, or SDK, to your app. We'll dive a bit deeper into the SDK later. For the Flood app, the Firebase SDK will collect and send data similar to the Google tag for websites. This data is processed into reports that could show you how many users are reaching a certain level in a gaming app, or it could tell you how many users made a purchase in the app and what those purchases were. You can also create custom events to capture what is unique and important to your business. For example, you can log events when a user signs up for a newsletter, makes a purchase, or reaches a new level on a gaming app. Once analytics processes the data, it can't be changed. So remember, when you set up your configuration, don't exclude any data you think you might want to analyze later.
Let's look at each level of a Google Analytics account, starting with the account itself. An account is a collection of properties whose data is owned by a single business entity. Underneath accounts, a property represents a grouping of user data, like from a website or an app. It's also the level where Google Analytics processes data and where you can create links with other products, like Google Ads. Underneath each property is a data stream that represents the flow of data from a website or an app to the property, and the level where you can control things like what data gets collected. There are web data streams for websites and app data streams for mobile apps. If your business has both a website and a mobile app, you may have a data stream for the website, a second data stream for the iOS app, and a third data stream for the Android app. Note that in most cases, you should use a single web data stream to measure the web user journey. To ensure consistent user and session reporting for web journeys that span domains, use a single web data stream combined with cross-domain measurement. When creating your Google Analytics account, you should map the account and properties you set up back to your business structure. In general, it's a best practice to set up your account structure with one account per company and one property per brand or business unit. Let's look at a few examples and how they've structured their account. The first business is a fashion blog that has a single website. Their account structure would look something like this. One account, since data is owned by a single business entity, one property for the website, and one data stream. The next business is a gaming company that created a mobile racing game for both Android and iOS. Their account structure would look something like this. One account, one property for the app, and two app data streams, one for the Android version and one for the iOS version. The last business runs a food delivery service. The service has two user bases, customers and delivery drivers. So they've created two different apps, one for each user base. Their apps are on both iOS and Android. And they also have a website with two distinct sections, one for customers and one for their delivery drivers. Their account structure would look something like this. One analytics account with two properties, one focused on customers and the other focused on delivery drivers. The first property for customers would have three data streams. One web data stream for the website, one app data stream for the Android app, and one app data stream for the iOS app. The second property for delivery drivers would also have three data streams. One web data stream for the website, one app data stream for the Android app, and one app data stream for the iOS app. These are just a few examples of how you could structure your Google Analytics account for your business. Note that Analytics 360 is an enterprise-level version of Google Analytics that provides additional flexibility for managing your data with things like subproperties and roll-up properties. new account and property. To set up a new Google Analytics account, first visit analytics.google.com and select Start Measuring. Then name the account and choose your data sharing settings. We'll name our account My New Account and select Next. You can create multiple properties under an analytics account, but most small or medium-sized businesses will have a single account and property, depending on the structure for things like lines of business, parent entities, and more. Name your property and select the time zone and currency for your reports. Then, you'll answer a couple of basic questions about your business. Let's say we're a medium-sized business. Next, you'll be asked to choose your business objectives. This step is important because it will generate reports specific to the business objectives that you choose. If you aren't sure, choose the Get Baseline Reports option. You can always change and customize these reports later, but choosing your correct business objective will make the reports more relevant to your business. Once you choose your business objectives and agree to the terms of service, your account and property will be created. Once you've created your analytics account and property, the next step is to create your data stream and start collecting business data. If you have a website, this means you'll want to create a web data stream. To tag your website, you'll first navigate to the Data Streams creation screen, choose Web, and then enter your website URL. This will generate a measurement ID and website tag specifically for your website. If you're using a website builder or a CMS system, you should copy the measurement ID and paste it into your website builder account. You can select your website builder to view instructions on how to add the measurement ID to your website. If you do not use a website builder, you'll need to install the Google tag on your website. There are two options to choose from. The first option is to use Google Tag Manager to install the tag. Google Tag Manager allows you to install code on your website pages and add to or change that code at any time using the account's interface instead of having to go back and edit the code itself. In addition, Tag Manager serves as a central place to manage and update all of your marketing and website tags. For this reason, we recommend using Google Tag Manager to install your analytics tag. If you are already using Google Tag Manager for your website, you can easily add the Google Analytics tag in your Tag Manager account. Note that you can also use Google Tag Manager with a CMS or a website builder. So instead of entering your measurement ID directly into the website builder integration for Google Analytics, you would create the Google Analytics tag in Google Tag Manager. The second option is to manually install the tag on each page of your site. When you choose this option, you'll see the new website tag listed in the UI. This tag will need to be installed on every page of your website immediately after the head tag. Once you install the analytics tag on your website, you'll start collecting many points of data automatically to the Google Analytics property. With a bit more implementation, you can even enhance your data collection with recommended and custom events, which we'll cover later.
In this lesson, we're saying Firebase, go to Admin, then click on Data Streams. Now, add a new data stream for your app's platform, iOS or Android. If your app is platform, for Android, you'll need your package name, and for iOS, you'll need your bundle ID. Enter the details about your app, and then click. Once complete, Firebase log event method in your app's code to define and collect up to 500 different event names with no limit on total volume. While the method of data collection differs slightly between web and app, with Google Analytics, you're able to analyze all this data together in one property to understand how users navigate across different devices, interact with your web or app, and perform actions that are important to you and your business, such as sign up, login, and purchases.
Once Google Analytics starts to receive data, the data first appears in the real-time report, and then in other reports shortly after. You can use the real-time report to confirm that data from your website is actually being collected successfully. First, check that user traffic to your website appears in Google Analytics. In your Analytics property, navigate to Reports and then Real-Time. If no data is showing, open up your website or app so that you're an active user. If data is being collected, you should see close to immediate real-time activity in the real-time report. The real-time report displays user activity that occurred in the past 30 minutes. You'll see the number of users as well as what devices are being used. For checking that data is properly being collected, you can focus on two main things. First, is there any activity shown in the past 30 minutes? Second, check that the data you expect is coming into analytics. Look at the event count by event name card. This card shows all of the events being collected from your tag site, such as page views and any click events that you're sending. This card is interactive. You can click through an event name to get the list of parameters associated with that event. And when clicking into a parameter name, you will see the value collected for it. For example, if you click on the page view event and then on the page location parameter, you should see the URLs for all of the pages that users visited in the past 30 minutes. If any pages aren't showing up as expected, you want to review your implementation. This is a great way to debug your data collection, where you can find some common issues and how to resolve them.